Welcome to True Projects. In this video, we are going to explain about a project titled Ship Detection using YoloV5. The automated ship detection in satellite imagery holds significant importance for military and political purpose. In military application, it plays a crucial role in identifying the enemy vessels, enforcing the ceasefires, and safeguarding the national water. In the political context, ship detection can be employed to enforce agreement between the countries regarding the shared water body and to monitor the unlawful fishing activities. Ensuring the accuracy of ship detection is a paramount as false positive or negative can lead to the serious consequences. Several techniques such as histogram processing, machine learning, and deep learning have been proposed for ship detection. In this study, we propose utilizing the YoloV5, a deep learning object detection framework, offers the rapid ship detection capability, processing the images within of milliseconds. Its efficiency makes it a valuable tool for both the military and political applications. YoloV5 has demonstrated the effectiveness as demonstrated in detecting the ships under various conditions, including the diverse weather conditions and different types of vessels. The objective of this project is of accurate ship detection and classification are of the utmost importance for ensuring the national maritime security and defense. With the availability of large-scale, high-resolution optical remote sensing images, numerous digital image processing methods have been addressed to address the ship detection in such imagery. However, many of these methods encounter challenges concerning the accuracy, performance, and complexity. In this research, we suggest employing the faster RCNN and YoloV5 algorithm for real-time ship detection. These state-of-art techniques aim to overcome the limitations faced by the previous methods and enable the efficient and accurate ship detection in optical remote sensing images. These are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know the flow of the project, the first one is importing the libraries. In this step, the necessary libraries and packages are imported, including the image processing libraries, deep learning frameworks, and the Flask for building the web interface. And the second one is exploring the dataset. The dataset containing the ship images is explored and analyzed. This may involving the tasks like data cleaning, data visualization, and understanding the distribution of ship images and considering the labels. And the third one is data processing. The ship images are pre-processed to ensure the uniformity and compatibility with YoloV5 model. Pre-processing include image resizing, normalization, augmentation technique to enhance the model's ability to generalize the different ship images. And the fourth one is splitting the data to the training and testing. The ship image dataset is divided into the two sets, the training set and the testing set. The training set used to train the YoloV5 model and the testing set used to evaluate its performance and accuracy. And the fifth one is building the model. Here, we used the two algorithms, that is RCNN and YoloV5. RCNN is a region-based convolutional neural network, is a traditional object detection algorithm that performs the region proposal and feature extraction separately. And the YoloV5 is a state-of-art object detection algorithm based on the you-only-look approach. It proposes the entire image in the one go and predict the bounding boxes and class probabilities for each detected object. And the sixth one is training the model. The YoloV5 model is trained using the labeled ship image dataset. During the training, the model learns to identify the ship and the images and predict the bounding box and corresponding classes. And the seventh one is user gives input. As user interface is built using the Flask web framework to allow the user to input the ship image for detection. And the eighth one is the given input is pre-processed for prediction. the user-provided ship images are pre-processed to prepare them for prediction by the YoloV5 model. And the ninth one is trained model used for prediction. The pre-processed ship images are passed through the trained YoloV5 model for prediction. The model will identify and localize the ship and the images, generating the bounding boxes and class labels. And the last one is final outcome as displayed. The final outcome, which includes the ship detection result, is displayed to the user through the web interface, providing the real-time ship detection using the YoloV5. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The images folder containing of different ship images within it. And the sample folder containing of the images that was used for testing the model performance. And the static folder contains the CSS, JS and Bootstrap files within it. And the template folder contains of the about, home, index, notebook, sign in and sign up of HTML documents. And the test folder contains the images and labels which is used for testing the model as of training too, and the same way that is used for training the model. And the app is an py file which is likely contain the information related to the front-end logic. It could include the code written in Python that handles the server-side operation such as processing user requests, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the notebook IPYNB file is a Jupyter notebook file which contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And the signup.db file appears to be the database file used to store the user information. For execution of the project, first we need to copy this address and open the Anaconda prompt. And our folder is present in the F disk. That's why we're writing this command and entering it. It will redirect it to the F disk. Here we need to write a command of cd space and paste this code folder address and click on enter button. And here we need to write another command, that is python space app.py. This command and the Anaconda prompt will be used to execute the Python script and perform a runtime check for any syntax errors and logical issues. After running this app.py file, we get the host application locally gets of default address, and we need to copy this local link and paste it on any web browser. I prefer to choose of Chrome within it and click on enter button. By this we get an home screen like this and we click on sign up button. The sign up button initiates the registration process. It will take you the registration page as of this, where we can provide the necessary details to create the new account. But my account is also pre-created, that's why I'm using the sign in button and giving my username and password as of admin, and click on submit button and click on OK button. Here we get a screen like this. Here we need to click on choose file button and selecting any one of these images and click on open button and then click on upload button. By this we get a screen of container ship. Like this we can detect the ship by using the YoloV5 model. In conclusion, owing the need of detecting the ship accurately and with high speed, the proposed method seems a very fit candidate for large-scale application for real-time ship detection. We obtained a high detection of 0.89144 with an inference time of 14.6 milliseconds, which can be used in maritime regulatory authorities and defense sector usage. The future work includes adding more images that contains the ships oriented in the horizontal or vertical fashion, improving the accuracy using the higher batch size, training model from the scratch without transfer learning, and trying the different sets of hyperparameters for a large number of epochs. These things require more computational resources and time. Nevertheless, it can improve the accuracy of detecting the ships.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.